Good morning everyone. Today we are going to study the chapter Light. Chapter 10 Light, Reflection and Refraction. We know that light is a form of energy and it excites sensation of vision, etc. we have studied in our lower classes, and also we studied that light travels in straight line known as rectilinear propagation of light. Anyway, light shows dual nature, that is particle nature as well as wave nature. About this you will study in your higher classes. Now, in this chapter, we are going to study two important phenomena shown by light, that is reflection and refraction. Now, first, what is reflection? Reflection of light means when light strike on a medium, different things can happen. Sometimes it may pass through that medium, or sometimes it may be absorbed by the medium, or it may be bounced back or reflect back. That is according to the nature of the medium. If the medium is transparent, it can travel through that medium, the light can travel through that medium. And if it is an opaque medium, either it can be absorbed or it can be bounced back. Now, this absorption or bouncing back depends on that nature of that surface where the light strike. If the surface where the light strike is highly polished surface, most of the light falls on that surface get bounced back. That we call as reflection. So reflection means bouncing back of light on striking a highly polished smooth surface. Now, mirror is a surface that is highly polished surface, and on mirror when light strike, most of the light fall on that surface get bounced back. So, most of the light get reflected back when strike on a mirror because it is a highly polished surface or smooth surface. Then, in our previous classes we studied about the mirror, the one type of mirror, according to the surface of this reflecting surface, two types of mirrors are there. One type is that the reflecting surface is a plane surface, which is known as plane mirror, about which we have studied in our previous classes. Whereas the other one, where the reflecting surface is a curved surface, they are known as spherical mirrors. Just we can recollect what happens when light strike on a plane mirror. When light strike on a plane mirror from any object, that object's image is formed. The characteristics of the image formed are: the image will be seen inside the mirror. That means a virtual image is formed. And also when you see the size of the image formed, we can see the image is of same size as that of object. And the distance of the image from the mirror will be same as that of the object from the mirror. And more importantly, the image formed in a plane mirror is always laterally inverted. Left side can be seen right and right side can be seen as left. So that is lateral inversion. About this we have studied in our lower classes. This is the way in which image formed in a plane mirror. Now, so that bouncing back, reflection is known as the bouncing back. Now, before moving to the topic that is spherical mirrors, we can see that the reflection follows it obeys certain laws known as the laws of reflection. That means a smooth polished surface can be represented in such a way, that is, the line shows the opaque surface, whereas the opposite side of that lined surface is the polished smooth surface, which is acting as a reflecting surface. Now, if a ray strike on that surface, smooth polished surface, that in that ray which is striking on the mirror, imagine this as a mirror, and if the ray strike on that mirror in such a way, that ray is known as an incident ray. Now after striking on that, it bounces back, it gets reflected back, and this the ray that is coming back after striking the mirror is known as a reflected ray. So this is incident ray and this is reflected ray. Incident ray and reflected ray. If we draw a perpendicular to the surface, a straight line perpendicular to the surface, that is known as a normal. This is a normal to the surface. Now we can see here two angles formed, that is the angle formed by the incident ray and the normal is known as angle of incidence, and the angle formed between the normal and the reflected ray is known as angle of refraction. So these are the two angles we are considering here. The angle formed between the incident and normal is angle of incidence, angle I, and the angle formed between the reflected ray and the normal is known as angle R. Now the perpendicular line is known as the normal. Now the laws of reflection says that always this angle of incidence will be equal to the angle of reflection. That is the first law. First law states that angle of incidence is always equal to angle of reflection. Second law states that the incident ray, the reflected ray and the normal all lie in the same plane. That means when the light strike on the surface and get reflected back, and when we draw the normal, this everything will be lying on the same plane. Light cannot bend and travel to another plane. So it always lie in the same plane. So these are the two laws of reflection. The first law states that angle of I is equal to angle of R, and second law states that the incident ray, the reflected ray and the normal lie in the same plane. So all the light rays that is undergoing reflection obeys these two laws. Now moving to the next type of reflecting surface that are known as spherical surface, and the reflecting surface are called as the spherical mirrors. Spherical mirror means the reflecting surface is a curved surface, and the curved surface can be two ways formed. It can be formed in two ways. If the reflecting surface is curved inward, it is known as concave mirror, such as if we draw that reflecting surface like this surface is that opaque, and the other surface that is curved inward. This curved inward surface acts as the reflecting surface. So the mirror in which the curved inward surface acts as the reflecting surface, then the mirror is known as a concave mirror. Whereas if the reflecting surface is bulged outward like this, here the reflection takes place from this surface, the outward bulged outward or curved outward surface. The outer surface is acting as a reflecting surface, then it is known as convex mirror. So spherical mirrors are of two types, concave mirror and convex mirror. So these two are spherical mirrors. Spherical mirrors are of two types, concave mirror and convex mirror. So we can imagine, we can understand it easily. Concave, from the word itself we can understand cave means curved inward, cave. So if the cave surface is the reflecting surface, that is known as a concave mirror. Now we can see some terms related to these spherical mirrors. Some common terms are there that are related to these spherical mirrors. Since the spherical mirror is a part of a hollow sphere, it's a part of a sphere, we can understand that when we imagine it as a sphere, we can imagine that this sphere is having a center. The sphere has a center, and that center we can call as the center of curvature C. At the same time, the center of this reflecting surface, is known as pole or P. So P or pole is the center of reflecting surface. Center of reflecting surface is known as the pole, that is denoted by the letter P. And imagine this mirror as a sphere, then that sphere is having a center. That center of the sphere of which this mirror becomes a part is known as center of curvature C. So pole is denoted as P. Now C, that is center of curvature. Center of curvature. So P, that is the point, is there on both type of mirrors, convex mirror as well as concave mirror. And this is also a part of spherical surface, so there will be a center of curvature here. The difference is here, center of curvature for a concave mirror lies in the left side or on the same side, whereas center of curvature of a convex mirror lies on the opposite side of the reflecting surface. In case of concave mirror, it lies in the same side of the reflecting surface, whereas in a convex mirror, the center of curvature lies on the opposite side of the reflecting surface. So here is the center of curvature C. An imaginary line that passes through this center of curvature and pole, that is known as principal axis. So here also there is a principal axis that runs along with that runs through the P and C. So that is principal axis. So another term, principal axis is an imaginary line that passes through the center of curvature and pole of the reflecting surface of the mirror. So the next thing is that imagine a parallel beam of light strike on this mirror. If a parallel beam of light strike on the concave mirror, after striking the mirror or after reflecting from the mirror, these rays passes through a common point on the principal axis. It bounces back and it passes through a common point on the principal axis. That common point is known as principal focus F. When a parallel beam strike on the mirror, after reflection they passes through a common point on the principal axis, on the principal axis, and that point is known as the principal focus F. Principal focus or F. Principal focus. Now in case of convex mirror, if a parallel beam strike on this mirror, here in concave mirror what we saw is after striking they converge, they came together and meet at a common point. But in case of convex mirror, when the rays strike on the mirror, after reflection they do not come closer, instead they move away, they diverge. So this mirror is also known as diverging mirror, whereas concave mirror is called as a converging mirror. Here the light rays reflected back, diverge away. And if we extend these reflected rays, if we are extending these reflected rays back, we can see that they appear to come from a common point. They are not actually meeting, they appear to come from a common point on the principal axis. That is known as the principal focus for a convex mirror. So in concave mirror, the principal focus is the point where the light rays actually meet after the reflection, whereas in case of convex mirror, principal focus is that point where the rays of light appear to meet after reflection. So that is known as the principal focus, F. Now, the distance between or the length between the principal focus and the pole is known by another term that is known as focal length. That is the focal length of the mirror. The distance between the principal focus and the pole of the mirror, that is known as the focal length. Focal length is denoted with the small letter F. That is focal length of the mirror, focal length. So, C is the center of curvature, so that the distance CPC, that distance we can call as the radius of this mirror, that is the radius of curvature. Radius of curvature, that is PC. Now the length of this reflecting surface, the width of that reflecting surface, that is known as the aperture. So here CP is the radius of curvature and FP is the focal length. So we can find out a relationship between here the radius of curvature and focal length. CP is the radius of curvature, exact midpoint is the principal focus, so half of the radius of curvature is the focal length. So there is a relationship between radius of curvature and focal length, that is radius of curvature is double of focal length. R is equal to 2F, or we can say focal length is always half of the radius of curvature. So this is the relationship between the focal length as well as the radius of curvature. So these are some terms related to spherical mirror that we have to understand. First one is pole. Pole is the center of the reflecting surface, and C is the center of curvature. Center of curvature is the center of the sphere of which the mirror becomes a part. Then radius of curvature is the radius of the sphere of which the mirror becomes a part. Then principal axis, the imaginary line that passes through center of curvature and pole is known as the principal axis. When a beam of light, parallel beam of light strike on the mirror, in case of concave mirror, after reflection it come and meet to the point that is known as principal focus, whereas it appears to meet on the point on the principal axis, that is principal focus for convex mirror. And the distance between the center of curvature and principal focus is known as the focal length. So these are the terms that are related to spherical mirrors. Now we are going to see the image formation by spherical mirrors. How an object can form its image with these mirrors. We know whenever an object is kept in front of a mirror, from that object, whether it is a luminous, non-luminous, whatever it is, from that object light rays strike on the mirror and it forms its image. It forms its image with the help of this mirror. Now that is the image formation. And when an object forms its image, from that object, from every part of that object, light ray arises, light ray starts and strike on the mirror so that its image is formed, either in the concave mirror or in the convex mirror. But practically it is not possible for us to show all the light rays that are starting from the object and show its image. So Here we are going to show the image formation by ray diagrams, and to construct a ray diagram we cannot show all the light rays that are starting from the object. So we are discussing some of the light rays, and out of that any 2 light rays are sufficient for us to make the image formation, to show the image formation of the object. So that rays are like this. In case of a concave mirror, convex mirror, and here is the P and C center of curvature, and this principal axis, and this is principal focus, and here again P and C center of curvature, the principal axis, and the point on the mid, that is principal focus. If a light ray that is coming parallel to the principal axis strike on a mirror, on a concave mirror, a ray that is coming parallel to the principal axis, always after reflection that ray passes through the principal focus. Whenever we draw the rays, we have to show its direction with the help of arrow. So when a ray strike on a concave mirror which is coming parallel to the principal axis, always it passes through the principal focus. And here again, if a ray that is coming parallel to the principal axis strike on a convex mirror, on a convex mirror, it move away, it diverge. And if we extend this ray back, this reflected ray, if we extend it back, we can find that this extended ray, if you extend it back, the reflected ray, if it is extended back, we can find that this ray passes through the point that is principal focus. That means the ray which is coming parallel to the principal axis, after reflection pass through the principal focus. This is the first type, the first ray that we can take to construct a ray diagram. Now, second one is that the second case is that if a ray strike on the mirror through the principal focus, if a ray strike on the mirror through the principal focus, after reflection the ray become parallel to the principal axis. If a ray strike on the mirror through the principal focus, after reflection the ray become parallel to the principal axis. That is for convex mirror also. If a ray that strike on the mirror, if we extend it, we can see that this is passing through the principal focus. So if a ray strike through the principal focus like this, here the ray become parallel. The ray become parallel to the principal axis. Now, the third case is that, so these are the two rays. First ray is coming parallel to the principal axis, goes through the principal focus, and second case is the ray which is striking through the principal focus becomes parallel to the principal axis. Now, the third ray we can consider, that is if a ray that strike on the mirror through the center of curvature, this ray bounce back through the same pathway. If a ray strike through the center of curvature, to the mirror, this ray reflects back through the same pathway. This is same for the convex mirror also. Now, for the convex mirror it is P and C center of curvature and principal focus. And if a ray that strike through the center of curvature like this, the extended ray is always shown as dotted lines. This ray, after reflection, it goes back, it bounces back through the same pathway. This is the third type of ray that we can take. And now, other than all these, if any other ray that strike on the mirror will be reflecting back by obeying the rules of reflection or the laws of reflection. If any other ray that strike obliquely on the mirror will obey the laws of reflection. That means the angle of I incident will be equal to angle R. By obeying that rule, the ray will be reflecting back. That is the fourth type, and that is also same for the convex mirror. P. If a ray strike on this mirror, by obeying the rules of reflection, the laws of reflection, that light ray will be bouncing back. So to construct a ray diagram for the image formation of an object, out of these four rays we discussed here, any two rays we can take to draw the image of the object. So only two rays are sufficient. Next we are going to see the image formation by a concave mirror. Image formation by concave mirror. Concave mirror can form its image in 6 different situations. The first situation is that when the object is at infinity, means when the object is very, very far away from the mirror, that is, the first case is the object, this is the position of object. Position of object is at infinity. Object is at infinity. How this image is formed? Object is at infinity. So, in this case, concave mirror and P, that is the pole of the mirror, then principal axis, C center of curvature, and F principal focus. When the object is at infinity, it is considered that the light rays that are coming from that object is always coming in parallel way. So when a parallel beam of light strike on this mirror, we know that, we have studied that first case, when a parallel ray of light strike on a mirror, after reflection, it passes through the principal focus. So, this is the image formation when for an object at infinity. The rays we are considering as parallel rays. So, if two parallel beams coming and striking on the mirror, after reflection, it passes through the principal focus. So here what happens is the image of that object which is at infinity is formed at the principal focus. We can obtain that image on placing a screen, so that we can call that image obtained by the actual meeting of this light ray. That image is the nature of that image, that is real image. Since it forms by actual meeting of the light rays and can be obtained on a screen by keeping the screen in front of the mirror, we can obtain that image on the screen. The image is said to be real image. And size of the image here we can see it's a point sized, very small sized. The image will be very small sized, that is called as point sized image, and usually it is upside down or inverted. So, the image formed on when the object is at infinity, the image formed on principal focus, and it is real image, inverted image, and of point-sized image. So, this is the case for a concave mirror when the object is at infinity. Now, moving to the next, that is Moving to the next is, when the object is beyond center of curvature. Now the object is coming little closer to the mirror. That is, now we are considering the second situation, that is beyond C, center of curvature. The object is now beyond center of curvature. So again,